Okay, we're going to go ahead and get started, everyone. So good morning, everyone, and thank you for joining Vicom and Microsoft for this special webinar titled The State of Azure 2020. We are very much looking forward to it. Please note that we will be recording this webinar today. My name is Andy Jonak, and I'm Director of Marketing for Vicom Computer Services, and I'll be hosting the event today. Today's event is being presented by both Vicom and Microsoft. Vicom is a Microsoft Gold partner, and we represent the majority of Microsoft solutions as part of our portfolio, and we've been a Microsoft partner for over 20 years. So now let me take a minute to introduce the people that are part of our webinar today. I'd like to introduce Donnie Hout, and Donnie is one of Vicom's enterprise infrastructure architects, and a big part of what Donnie does is helping organizations with their Microsoft/Office 365 and Azure environments, and helping to make sure that they function efficiently and securely. Donnie's responsibilities include helping firms evaluate technology, implement technology, integrate it within their environments, and make sure it continues to provide value. And as I mentioned, a big part of Donnie's focus is on the Microsoft portfolio for Vicom. I'd also like to introduce our featured speaker for today, Dane Johansson with Microsoft. Dane currently serves over 100 customers on the East Coast of the US as an Azure technical sales consultant, as well as leading a team of Azure Cloud Solution Architects. He's been with Microsoft for over 8 years and considers himself an Azure aficionado, which is a great term, by the way, where he travels around the US, on-site and, of course, now virtually, helping customers understand and adopt Azure. We are thrilled to have Dane with us today. So let me go through the logistics for today. The event is scheduled for 1 hour total, and we will then leave time at the end of the presentation for questions with a formal QA session. But if you do have questions throughout Dane's presentation, please feel free to send them through the chat window and I'll feed them up to Dane. All attendees will be muted throughout the presentation, but anyone can unmute themselves for the Q&A. We hope that you find the webinar and the information presented today to be intriguing and, most importantly, useful, as most of the firms we work with today are embracing the cloud in some way, and many of those are considering or using Azure. So with that said, thank you again for joining us today, and let's go ahead and get going. Today's IT and cloud environments are increasingly complex. We all know it, as frankly, we all live and breathe it daily. What's happening with today with the pandemic also makes IT and cloud environments more important than ever to a firm's success. But while most are considering the cloud in some way, and many are using public clouds in some fashion, there's still a lot of mystery to it for many. We see that firms are looking for help in defining and validating their cloud strategies, and then they're looking for help in adopting them. So this is where Vicom and Microsoft can help, and it's what we're going to talk about today. Our goal with the session is to help demystify the public cloud to help firms adopt the cloud more strategically than they are right now. Let me take a quick minute to tell you who we are as well. So the organization that we are part of is Vicom Computer Services, and Vicom is a full-service multi-cloud infrastructure provider that helps firms with their IT and cloud infrastructures to help them wherever they might be throughout their digital transformation and or cloud journeys. Our domains of expertise include IT infrastructure and multi-cloud solutions, networking, operations and service management, enterprise, network and endpoint security, staff augmentation, and professional and managed services. Our solutions and offerings can help organizations wherever they sit in regards to the maturity level of their environments, solutions, or overall needs. So that's a little bit about Vicom and what we offer. So now I'm going to go ahead and turn it over to Dane from Microsoft to lead this timely discussion about Microsoft Azure. Dane, I'm going to hand the ball over to you now.
Awesome. Thanks, Andy. Appreciate it. All right, guys, let's dive in here. I'm going to share my screen. And then, Andy, I'm going to ask for your confirmation that you can see it. Hopefully you can see a black screen that says Microsoft Azure on it.
Yep.
Okay, everybody. Well, hey, great to meet you. We're going to dive right in here. So this is supposed to be a fun session, right? So I'm here to educate and inspire. I eat this and work around this all day pretty much. So and what I find is most people they just need a demystification experience. So I'm going to actually give you a virtual data center tour today, in addition to just talking about big picture Azure. And by the end of this, I hope you walk away with some ideas on how you might be able to use it. So a couple things, right? So there is actually a journey to get to public cloud. When we talk Azure, that's what we're talking about. I normally ask people if they think about where they are in the journey, looking at these 6 areas, where do they think they need to do most of the work, right? And there's actually there's a science and an art to each one of these. ultimately, when you think about choosing to use Microsoft Azure, the question you're asking is, do we want to continue to run our apps and our data in our own data centers? Do we want to run them in Microsoft data centers? Do we want to do a little bit of a mix of the both? And so as we do this, what you tend to find is that the reason that people start putting applications and data services in public cloud is typically for one of these 6 different motivations. This fits into there. And all of this ultimately comes down to, can we actually use our IT to help the company make more money, in addition to saving money, reducing risk as well? The challenge is, though, is everyone's super familiar with this on-prem world, but people are super unfamiliar with what's available and what's possible in our data centers. And so this is the mindset that I coach just organizations, both consulting orgs and just customer orgs, kind of around there's been some global touch, but mostly here in the US, just on how to get started with thinking about the plan. And then I find that everybody typically needs a tour like this. So let's get under the hoods. Let's talk about just what goes on with Azure behind the scenes here. So Mark Rusinovich, he is our Azure CTO. He has done these inside Azure data center architecture sessions for a couple years now, does them at Ignite. You can actually find his most recent one online. And so I actually take some of what he has, but I add a bunch of stuff to it as well. So just want to call him out. He's one of our champs here. So let's start big picture, like Azure on a global scale, and then we'll actually dive down into a specific data center campus, or we call a region, and then we're going to get down into the platform and some of the services and how you can actually use this thing, right? So this is Azure today, right? So there are, if you look in the top left, there are actually 60 plus regions worldwide. Region is synonymous with data center campus. So each one of these blue sites is actually, there's multiple data centers there. In 2019, we stood up 8 new data center campuses, and for 2020 and moving into 2021, we've already built and or are building 10 new regions. And so actually, if you take a look here, you can see these are some of the new locations that we've actually already started building or have already built some new data centers. And then we just recently announced in October that the US, that we were going to build another one in Arizona. This will be called the West US3 region. We're doing some really interesting things with the actual design and construction of the building using some of our own technology, some of the augmented reality with HoloLens 2, some of our spatial anchors, which is a 3D building modeling service in Azure. What you'll notice with our data centers is that we really aim for sustainability, and so we're doing some really cool stuff with water cooling in this data center, where basically for half the year we won't use any water to cool it. Very sustainable, and also this is very economically friendly too. We're creating a lot of jobs and putting a lot back into the area with this. So if you look in the upper right here, a couple more things about a data center campus, right, is when we build them, we try to put at least 2 of them in any particular geopolitical area, right? So if you look around at these different countries, you're going to find there's typically at least 2, except for South America. You look at it, you say there's only 1 there. Well, typically South America, per their data sovereignty requirements for disaster recovery, high availability, they've been able to peer with one of the East US data centers. We now have one in Mexico though as well, so that kind of covers the grid from that perspective. Most of the clouds are what we call commercial clouds, meaning if you have a credit card and an account, you can sign up and you can start using our services without any person getting involved. There are some clouds that we call sovereign clouds, where based on just local restrictions around data sovereignty, like in China, there are a couple in Germany. We think about the US government and Department of Defense data centers. You have to be a specific kind of customer to get into those. We do build and operate all of our own data centers, with the exceptions of the ones in China. Those are operated by 21 Vianet. That's just per their government's restrictions. And then we can build them really fast. So if we want to go into a new country, which we do every year, multiple countries, we can actually go in a modular fashion where we can go into a trusted colo. And if we see demand uptick, then we just decide we're just going to go and build. So this has been an ongoing kind of science and art we've been working on. And then all the data centers are pretty much the same, meaning when you use them from the portal, you're going to find most of the same services, and pricing should be similar. Pricing will differ based on the cost of power and cooling, or the generation of the data center, or the cost of taxation in that region. But generally, they should be the same. You will find some services, some of the newer ones, or some of the services that are a little more, they're a little more uncommon, where we'll only put those in what we call hero regions, because there's just not enough demand just across the globe to put them in all of them. And so all of these data centers, now we do connect them with our own fiber backbone. So this is a satellite view of our global WAN. You can see we lay a lot of subsea cable, over 130,000 miles, that grows pretty much on a quarterly basis. We laid this huge piece of glass, this Maria cable with Facebook a number of years ago that stretched the Atlantic, 6,600 kilos of glass, 8 fiber pairs, 160 terabytes per second, or terabits per second. And then you'll notice on the backbone, you see the blue circles for the regions, the campuses, but then you see these little light blue squares. These are essentially, these are the front doors to get onto our backbone, right? So these are our edge locations. So this is where we peer with all of these ISPs, right? So we've got about a 2,500 plus ISP interconnection strategy. And the whole reason for that is, right, is if we connect with everybody, it's less hops for you to get on the backbone and to get into one of our regions. And how you can think about this is essentially you can, using one of our services called Azure Front Door, you can actually get in on our backbone somewhere else in the world and then ride our backbone to get into a region in another part of the world, right? So all of this essentially is provided to you as a service. And what's really cool about this is there's really no magic with the hardware. All the magic is in the software. We buy the same kind of standard switches and such that you would. We've just made a lot of investment in how we run this from a software-defined perspective. Now, if we were to drill down into one of the regions, right, let's say this white box here represents a region, a campus, and these little gray symbols represent data center buildings in that region. What you'll find is that there's multiple data centers, right? And what we try to do is we try to divide those data centers up into zones. Now, what a zone is, it's a delineation of power, cooling, and networking, right? So these two data centers in zone 1 as compared to these in zone 3, as compared to these in zone 2, they would all have different power, cooling, and networking sources, right? And so think about what we give you. We actually give you layers of resiliency that you can play with, right? Risk is like a cat. Do you want a kitten on your lap or do you want a lion? We leave that up to you. And so, for example, you could take a highly available, SQL cluster, and you could run 2 SQL servers on different physical nodes in different racks and different clusters in the same data center, or across 2 data centers in the same zone, or across 2 data centers across 2 zones, right? So it's really up to you how you want to do it. We make it really easy for you to configure that. And then ultimately, if you need that geo resiliency, all of our regions are paired. And so you have the ability to go like a hot across 2 different regions, right? All across our backbone, or you could do failover, failback from one region to another. And in fact, from the storage perspective, we actually literally make it as easy as clicking a button in the portal to replicate your storage copies from one region to another, right? So we do believe we can help you achieve the availability that you need, but we also think we can help you do it in an easier, more cost-effective fashion. Now, from a network perspective, if you were to look down at our network, right? So I'm going to call this out. See this box here? This is that region, right? We were just in. The little gray boxes are the data centers in their respective zones. And then you see here's some other regions, right? And they're all connected on the backbone here. In every region, you have these 2 physical implementations, buildings actually. They're called regional network gateways. There are 2 of them, and you can see how all of the data centers are redundantly connected to those RNGs, which are redundantly connected to the WAN, which are also additionally redundantly connected to our peering locations, right? So essentially what this is as we build data centers, we decouple the data centers from the RNGs, from the network gateways. And so what happens is if we want to scale out a data center, we just go build more data centers, hook them up into the RNG front end, and we're live on the backbone, right? And then you can see coming in from the outside, you have the ability to come into Azure through the public internet, right? HTTP, HTTPS, RDP, SSH, however you want to do that. Or you can zip across a private MPLS route. You could run IPsec across either one of those. It's totally up to you. But again, hopefully this gives you some perspective on how the network runs and how we make it work at scale. And then what's interesting is because we run this at scale, we actually built this this clone of our network called Azure Network Emulator. This runs on Azure. It's an internal thing from Microsoft. And what we do is we actually throw configs and updates at this. There's a lot of testing scaffolding around it. We throw those updates and configs at this first to catch potential bugs before we push out to the global network. And so this has been actually a very successful kind of back end, you don't get to see it, thing we have to do to run at hyperscale. It's just kind of cool. And then now there, as you can see, there we're talking a lot of data centers. There's a lot of servers. There's a big carbon footprint potential here. Microsoft, we're actually by 2025, we plan to be 100% sourced from renewable energy sources. In fact, you can kind of see today, this is kind of what our footprint looks like from a renewable energy source perspective. We're doing a lot of work with wind farms. We have a very big one in the Netherlands. We are actually the largest consumer generator of solar power in the state of Virginia at 350 megawatts. I think that's bigger now. This slide's a little bit out of date. And so very excited. We do have the LEED Gold and Zero Waste certification. And I will call this out at the bottom. Our data centers on average are about 93% more efficient than a traditional data center. Let me explain that. So there is if you wanted to you see how effective your data center is with its use of power, there's a rating out there called PUE, power usage effectiveness. The traditional data center is like 1.6 to 1.7, right? So a perfect rating is 1.0, right? Meaning 100% of all your power is going towards compute. But typically there's a bunch of power that goes towards cooling, right? So if you're dropping in a traditional data center $100,000 on compute power, you're dropping probably another $60,000 to $70,000 just to cool the heat coming off those servers when they're computing. Well, our average PUE across all of our data centers, right, our earliest ones and our newest ones in Azure is 1.189, and some of our newest data centers are down to 1.06. Why that's beneficial? It's very green and sustainable. First and foremost, it's more cost effective for us, and thus it's more cost effective for you because that passes on to you through the prices of our services. Now, in this, right, because we fight for sustainability, we don't just do a lot of R&D around software. We do a bunch around like energy. And so we're doing some really cool experimentation with these next-gen fuel cells where we think we can double our energy efficiency and reliability. We're doing some really interesting things in replacing just what you'd think about as kind of current state UPS systems with these flow batteries, right? Where instead of having enough juice for 20 to 30 minutes with a UPS, imagine having hours of it, right? So you never have to fill over to the generators, right? Which again is a big cost saving. It's also very sustainable as well. And then we're also playing with some really unique, interesting energy sources. So if I had you guys one-on-one, I'd ask you to speak out on this, but curious if you can look at this and tell me, what kind of power source this is. It's actually, this is natural gas coming in here on the top, and then here's the server workload underneath. So in our Wyoming data center campuses, this was the existing power grid, and it would have cost money, and it would have been a lot of extra effort to go and bring in a different one. So we just actually tapped this, did a bunch of R&D to figure out how to harness the natural gas to power the server. So really excited about that. And then ultimately, as you come into Azure, there's a calculator out there that will actually tell you how much you reduce your own carbon footprint living in our data center. So when you think about ethical supply chain with customers, you think about marketing, branding, and you think about honestly just having conviction that you're being a good global citizen. Not only do you benefit from Microsoft from just a performance, availability, security perspective, but you do benefit from a sustainability perspective as well. Okay, now all this being said, there's a lot going on here, right? So there's a lot of different compliances that we have to cover ourselves, but also enable for our customers. And so we do have more than any public cloud provider, namely I'm going to call it Amazon and Google because they're the other big two. We do have the broadest set of compliances today. This is a shared responsibility model, right? So ultimately, if you want to access these things, you can just go into the Service Trust portal and you can actually go and you can pull these reports. And then we provide a lot of guidance just on how you can go and do your part to cover compliance as well. In fact, there actually is an AI-backed service called Compliance Manager that looks at kind of all your cloud services estate with Microsoft, including Azure, and will tell you how you score in actually hitting your compliance, and then we'll provide recommendations on achieving that. But that is in place. And then from a security perspective, this also is a shared responsibility model as well. And so again, we think about from a logical layer and definitely from a physical layer, that's on us. So, and you can kind of get an idea of what we do here. And then from a customer perspective, you are responsible for the applications, the OS environment, right? And then any of the data services. And what we'll do is we try to take a lot of security and bake it back into your layer. So that's even easier for you to do your part. So I'm gonna talk a little bit about how we do our part, namely from a physical perspective. So if you were to actually, if you even were able to find one of our data center campuses, if you could even do that, first and foremost, right? And if you come through legally, right, there's a background check and a system check just even to get there. Then if you find it, like visualize this, there's a perimeter fence, there is a front entrance gate, there is only one defined access point with ongoing video coverage and ongoing roaming patrols. And then once you get into the building, there is a number of different, there's two-factor authentication with biometrics. Again, no building signage, you don't necessarily know where you're going, ongoing controls, video coverage. And then lastly, just to get into the server environment, right? So you can see layers upon layers. Very challenging for you to get in. I find most customers when they see this, they go, man, like we don't do hardly any of that kind of stuff, right? And then from a logical layer, right, the software platform, there's actually a lot that we do from a security perspective as well. And one of the things to note about Microsoft from this is we actually feed the hardening of our security posture for our part of the model and also for your part with a ton of security insight, right? So like think about this, like Microsoft on a monthly basis analyzes like 400 billion emails, right? Or like the amount of telemetry from security products or from just some of our cloud services, 1 million telemetry events per second, 450 billion monthly authentication. So we're always looking for the big bad digital nukes that people are designing out there, and we're trying to get ahead of them so we can stop zero-day attacks. And so what we've actually done is we built this thing called the Intelligent Security Graph. And so essentially we've got a number of different security services in place, basically in addition to our products, to harvest this data. And we're taking all this data, we're following privacy and compliance standards, right? Pulling this data in, we're collecting it, normalizing it, analyzing it, and then we publish it to our product teams internally, who then are working with that data and using that to bring hardening into those products and then pushing them back out to customers again, right? And so there's actually ways that you can tap this, and a lot of our security services actually are built on this that you can use. For example, we provide DDoS for all Azure customers just as a default under the hood, like it's there, right? But if you want to actually use our Azure DDoS service to tune it specifically for one of your applications, you can use so, and this feeds off that intelligent security graph, right? It's all part of the service wrapped up for you. There's another service in Azure called Security Center, right? Security Center, essentially, it uses artificial intelligence to look at your services to detect vulnerability, provide recommendations where you should harden your posture across whatever Azure service you're using, as well as detect suspicious or anomalous activity that you should investigate. I could do a whole session just on this. It's amazing to dive in. It's actually free for some of the advanced functionality you do pay per service you use it for. And then I don't know if some of you guys are out there if you're using a SIM, but we do have a cloud native SIM in Azure called Azure Sentinel. You can actually get a look at it. It's a really clean, modern interface today. It integrates super well with Microsoft 365 and all the Azure services, and can also talk to some of your other SIMs if you have an existing SIM already. So really nice canvas for basically drawing out conditional remediation plans. There's actually a really nice hunting experience for diving down into incidents. And then there's this really cool canvas graphic designer where you can actually break out a potential incident to triage it, investigate it, and figure out if it's something you need to shut down. So you just get a look at that. And then this is a marketing page. I just want to call this out. We actually call that 97% of attacks against customers who run in our data centers, they're remediated. So like, again, we do this for you without you even necessarily thinking about it or batting an eye. And part of that is because we do employ like almost 4,000 security professionals on a daily basis who are salaried and incentivized to go and fight kind of on your behalf, right? We care about this for ourselves. We also care about it for you as well. So, but you do have to do your part. Now, ultimately, on the platform is we do have all this hardware, right? So we do design our own hardware. Someone else manufactures it. We do design it. It's a big open source project that we lead and contribute to. And then our data centers, there's actually not a lot of people that we need to put of all these data centers to run them, right? Aside from some security teams and such. But we run Azure using a lot of machine learning driven controls. There's a lot of Internet of Things telemetry going on, and there's a lot of automation. We actually basically say that the platform it runs itself. It's in some regards we call it self-healing. And so this is just part of the hyperscale project. That's why you can go and spin up Azure without getting any people involved on the backside. And then our data centers, from a data center availability perspective, across our entire fleet, we're 5 nines. Right, there's a lot of work that goes into that. And then from a service level perspective in the data center, we do have this status page where we basically report it's less than 2 minutes, so it's near real time, the status of every service and if it's available, just in every region across the globe. And then if we ever do have an interruption, we do publish an RCA, very detailed, on what we're doing to fix the situation and ultimately what happened, how do we fix it, how are we going to get better in the near term. And then we do back all of our services with financial backed SLAs, right? So, and if we violate it, if you adhere to the SLA, we will actually credit you back, and you'll see that coming to your next month. So here we go. Okay, pictures. Let's get into this. So now that you kind of understand, right, we talked about our region, we talked about each of those data centers in that region. Well, here you go. This is Quincy, Washington. This is one of our big, our flagship regions. You can see this is actually an office building here. You can get an idea of size when you look at the door and you compare some of these cars. And so you've actually got 4 buildings here. You can see that we can easily expand around here as we need to. There's actually a video of this guy named Alexander Bradley. He's kind of the face of Microsoft 365. He's standing like right here, and he actually walks down here, and he takes you on like a 10-minute tour of the Azure data center, and he goes through a lot of those physical controls to get in. And he does that for Microsoft 365 because it runs on Azure, right? So he actually goes through, so you get to see some of that stuff. If we go a little bit to the southeast into Wyoming, you will see some of those data centers I talked about where we harness natural gas, right? This is Wyoming. You can see the design is a little bit different, right? It differs based on the generation and the place that we actually build it. This is actually in one of those data centers. These are storage clusters. So we don't run SANs in Azure. We just run low commodity, reliable hardware, right? And it's all software defined on the front end. And so there's big load balancers and web servers and all that. And so these are storage clusters. You can see how clean it is in here. You can see the UPS, the batteries on top. And then if you were to walk in here, you'd actually notice it's actually kind of warm. We do run it warmer than your traditional data center just because of how we do the cooling. We can actually save a lot of money by not pumping as much cool air or cold water to bring that down. And so you would notice that if you walked into one of these campuses. We do some interesting things with design as well. We don't just build out, we build up. So in Singapore, you can't build out, you have to build up. And so this is like one big, huge glorified refrigerator. There are multiple data centers within that one. This is a zone, so there's another zone nearby as well. Part of this design is there was extra design and construction that went into the reinforced flooring to support the workloads as it went up from one story to the next. And then as we build out, we really build out, right? So this is Dublin, right? So in Ireland, this is one of our flagships. So DB3, that was built in 2010. DB4 came out in 2013. And then you'll notice right behind it on what looked like a fairway, we built DB5 in 2014, right? Now, from this picture, if you look, there's DB3, 4, and 5. In 2015, we built DB6. In 2017, we built Dub 7, and then in 2018, we built Dub 8, and then we've been continuing to build. This slide is out of date, so I would assume there's probably some more data centers sitting there as well, but we just continue to expand, and you'll notice this at many of our flagship sites around the globe. And just curious if you can look at this, if you can tell me, you don't have to tell me, but if you think in your mind, do you know what that is? Most people don't get it. That's actually a big industrial vacuum, and this is a dry shredding machine for disposing of disks. So again, we do that for you. So you do find that stuff in our data centers, but you don't have to worry about that stuff. Again, when you're buying hardware, you think about, repurposing or putting it off or selling it off to somebody. Yeah, again, we take care of that for you. And then this may look like, it kind of looks like an Airbnb vacation home on top of one of the data centers. This is actually a big HVAC unit, just one of them, right? There's a whole bunch of them on there. So again, it gives you an idea of scale and what we put in. Now, we're doing some really interesting things. As you know, we care about sustainability. And then data centers, you got to realize it's also difficult to find the best land for, right? You can't just build a data center anywhere. You certainly can't build it on a fault, and land's really expensive, and there's always a land grab. And then you have to think about latency. Can you get it close to where most of business takes place, right? And most of business around the world takes place on the coast. So we actually, a number of years ago, we decided to see if we could run Azure data centers underwater. So this Project Natick was born. Some interesting things called about it. So we've been essentially testing this off of Scotland. It's all renewable energy, and it only takes us 90 days to deploy this thing. And what's really interesting about it is it runs in lights out mode, right? So no one needs to touch it. So it can just sit there for like 5 years. So here's a picture of it. You can get an idea of, you can see this guy down here. It shows you how big that thing is. And there's actually a video of this going down. And this is V2. There was kind of a V1. This is V2. We were pretty skeptical on V1, but by the time we got to V2, we were starting to see some initial results that we moved on to V3, which is we just take a bunch of these server capsules, drop them on ballast tanks, which we can use to lower and raise in the water, and then we just hook up all the subsea cabling and connection and all that kind of stuff. Give you an idea of how big this is. That would be if you were to set that on the field where the Seahawks play. And so anyways, so very, very exciting stuff. And what's interesting is there are this whole idea of a lights out environment. You don't have to touch it, just sits there. It has some really promising potential, right? So you think about putting servers in an oxygen environment above water, right? Like you've got oxidation and moisture you have to deal with. You've got particle contamination. You just have the issue of dealing with like thermals, right? How do you recycle and move air around? And then ultimately people have to touch this stuff because they're maintaining it, all that kind of stuff, right? So there's a lot of potential risk to reliability. But when you do this underwater, right? We run these capsules. We suck all the oxygen out, so it's a low moisture nitrogen environment. So you essentially You don't have oxidation and moisture issues. You don't have particle contamination, and you certainly don't have the same issues with thermal cycling, which means no one has to touch it. So you run it there for 5 years, and then you can pull it back up. So what we're finding is, you guys probably saw the fish there. I always throw this slide in. We actually use some of our own AI services, AI for Earth, to keep our eye on some of the marine wildlife that is there. We have found that it's actually very sustainable. We don't affect the temperatures of the ocean. Wildlife has been absolutely fine with their new neighbor that's been sitting next to them. You can see the fish there again. But what we're finding with this is actually 7 times better performance. And so actually earlier this year, a couple months ago, we actually just published a big public report on this. You can see we actually pulled it up. And the whole idea is, again, how do we put data centers closer to people? We get things out on the edge. And so very, very excited. I don't think it's very long before you may have the chance to basically provision a server underwater. So who knows if we're going to call these, Atlantis region or whatever, but we're moving in that direction. Now, there's this other thing we just announced. It's called Azure Modular Data Center. This is interesting. When you think about these Azure data centers, the pictures I showed you and the Project Natick, right? These are data centers that you share them with other customers. Like we all share them, right? It's public cloud. But we actually introduced this new thing called Modular Data Center. We actually will give you a data center, right, that you can use yourself. And you see it called out here, right? So scenarios that range from mobile command centers, humanitarian assistance, military mission needs, mineral exploration, other use cases requiring high intensity compute stored on Azure. We'll actually give you this big, or it's a mini data center and hook up so you can actually see some of the cabling running in to the power generation here. You can see a picture of one sitting here on a tarmac, and then you actually see this one's in transport, right? Just sitting right on the actual semi-trailer. And then what's interesting about these things is we can take these anywhere in the world, deploy them, and we've got this brand new satellite connectivity network that we've built out, just first party, but also with third parties as well, where you can see if we had this modular data center, this MDC running over here in the globe, using the redundant satellite connectivity, we could actually connect it back to just the broader private network or the public network. And so very excited about this. This is new, but it's been in R&D for a while. And so I don't think any of you may use this, but who knows, maybe you will. It's just good to know kind of where we're going with this stuff. Okay, so doing a time check right here. We're at 36. Great, perfect timing. So I'm going to now dive into the platform, right? So now you guys have an understanding of like the physical aspect, what's going on. Let's talk about like what actually goes on, the platform aspect of it. So this would be the architecture. We talked about the infrastructure, right? There is this service called the Fabric Controller. This is basically the operating system of the data center. Fabric Controller provisions all the services, manages it, all that kind of stuff. It's the brain of Azure, right? On top of Fabric Controller runs this software platform called Azure Resource Manager. Azure Resource Manager houses all of the different Azure services that you can provision, and it provides a number of different services like role-based access control, activity logging and telemetry, subscriptions, resource naming, resource grouping, resource tagging, all of the resources that are all the little services and functionalities you need to manage these resources in a cost-effective, performant, available, secure, organized fashion, right? And then ARM is who you talk to, right? So you can do it through the GUI, the portal. You can do it through any of the shells, whether you want to go like PowerShell or you want to go Bash through the Azure CLI, or you can do it programmatically through an SDK, right? So if you're into like Terraform or like Ansible or Chef or Puppet, they actually write their editors to talk to our REST APIs in ARM so that you can use their languages to provision resources in Azure, right? So this is a constant evolution. We're always trying to figure out how do we lower cost, how do we maximize resource usage, all that kind of stuff. And then in ARM, you have access to all of the different services, right? So, and I like to talk about Azure like it's like a grocery store, right? So, and when you go to deploy an app in Azure or you run a data service, it's kind of like making a meal, right? You follow a recipe and you deploy it. So when you go make like a meal, like a stir fry, you go to the grocery store, you got to go to the protein section, you got to get some noodles, some rice, right? You got to get some veggies, you got to get some sauces, right? So you kind of shop around the store, different aisles, different categories. Same is true in Azure, right? When you want to deploy an app or deploy a data service, you basically will pull from a variety of a la carte services and pull them together kind of in granular but collective fashion so that you can actually run your workload. Then you can kind of, they're decoupled, right? So you can move them in and out as you need. It's kind of like Legos, which makes it very exciting, especially once you get started in Azure. So if you wanted to provision some services in Azure, this is actually how it would work. So let's say you're in the portal and you basically follow the wizard, you create a virtual machine. That request is submitted to Azure Resource Manager, who looks at it, right? It basically validates you based on role-based access control and certain policies that you've configured as like a governance scaffold. Then it says, okay, this is legit. So then it talks to the resource providers and says, okay, we have to stand up a VM. We need a VM. We need some disks. We need a virtual LAN. And then the resource providers will go and talk to Fabric Controller, right, who runs the data center. And then Fabric Controller will go, and what we do is in our data center, we have compute clusters, right, for hosting your operating system. That's where your cores and your RAM are. There's a little bit of temporary disk there for like virtual RAM. And then your persistent disk, right, your C drive, and then your E through Z drives, they're going to live on storage clusters, right? And so what happens is you get this decoupled system. So your OS image gets deployed on a node, on a rack, in a compute cluster, right, with a little bit of scratch disk space. And then your boot drive is on a storage cluster where you can attach any of your E through Z drives, and they're all replicated for redundancy in the backside. And then you essentially just remote in. So you get this decoupled computing experience, just like you kind of do on-prem with like a host ESX node and your SAN, except we don't run SANs. And why this is really nice is you can actually stop the compute portion of your server while still persisting storage and not pay for the compute, right? Which can save you big money on certain workloads. And then also you can change your hardware SKU anytime that you want to, right? You just have to stop it, reboot it, right? And you can change your disk as well. So again, it's this whole idea, this Lego, it's elastic. Change it however you want to. You're not married to what you just bought from one of the big hardware providers. Okay, so now think about this. So ARM is the face, it's the interface for you. It's like the desktop interface for Azure for any region around the globe, right? So it's the global interface. Why I call this out is technically this is ARM here. ARM allows you to provision and manage resources in Azure using these, it's basically using guest agents, right? Well, we basically found a way to take similar agents designed for on-premises workloads where you can now take an agent and deploy it on-prem in GCP or Amazon, and you can essentially then take those on-prem or other cloud resources and project them into the Azure resource management plane so you can manage them along with your Azure-based resources from a single pane of glass. So like, I'll give you an example here. So this is a screenshot from the portal. So I'm looking at all of my resources currently. Notice how 5 of these servers, they're Arc enabled, meaning they're not running in Azure, but I'm basically managing them from an inventory perspective, right, for compliance and state from the Azure portal. And then additionally with Azure Arc is not only can we project a metadata avatar of a resource from a different cloud or on-prem into Azure, but we can actually take an Azure native service like Azure SQL database, right? It's a managed database service, and we can push it to run on the edge in your data center or in another cloud. So look at these 3 Azure SQL databases, right? You get all the benefits of the managed database, right? And we're going to update it. You build it through us, but you can run it in your own data center or in another cloud. Like really, really cool stuff. I'm super excited about this. Is only going to get better. And then now let's just say though that you want to do more than just push a couple services out. Maybe you want to run more of the whole Azure stack on the edge or on premises. So we've got this Azure Stack family. You've got the Stack Hub where this is literally the pre-configured hardware software platform. It's got Fabric Controller, it's got ARM in it, it's got the resources where you can run this, and you basically have this little private instantiation of Azure in your data center, right? So like our cruise lines customers like Carnival, like they run these on their ships, right? So they get that same Azure management and service experience out at sea, and then when they come back and dock, they hook it up to the internet, they run it back up to their mothership running in public Azure, right? And then you've got Azure Stack Edge, which is like, imagine needing to do really fast computation or like AI computation on the edge out in the middle of nowhere where you can't zip back to the public Azure, right? So you see like folks who are doing like when they're checking like they're using drones to check power lines, like they'll run this on the truck as they drive by the power lines, and that drone's talking to this thing, and that data's coming down from the video on the drone to this edge device, right? Same Azure management development experience, and the AI is running right there. Our pre-built AI servers are running right there, crunching that data, talking back to the drone, and then which is signaling the guys in the truck that, oh, there's a repair that's right here, stop, go fix the line, right? So really cool stuff there. We actually build this one ourselves. And then Azure Stack HCI, which is probably most interesting to the masses. Stack HCI, essentially, it's its own OS. It's basically a combination of Hyper-V, our storage spaces direct, and some software-defined networking. And it can sit on a whole range of validated partner hardware. And what's cool is, I don't know if any of you have seen the new Windows Server 2019 Admin Center. It's all web-based, really, really cool. You can actually use that to manage it, and it's integrated to talk to Azure services. So I'm going to give you an example here. So essentially imagine going and basically, instead of buying a SAN and all that, you just buy a couple nodes from one of these big partners, you install Azure Stack HCI on it, and it naturally integrates with Azure. So for example, I'm using Windows Server 2019, the admin center here, to look at those VMs that are running on that HCI cluster. And you'll notice just by clicking a button, I can actually protect the VM to Azure. What that protect means, there's a failover and failback service in Azure called Azure Site Recovery. It's integrated with Azure at Stack HCI, and so you can easily configure that to talk to Azure on the backside, right? So it makes your life a whole lot easier, super cost effective too. But we do the same with Azure Backup. We do it with some monitoring. We do some security stuff as well. Very, very exciting stuff. There's a lot of buzz going on about Azure Stack HCI. I have a couple customers right now. I'm doing some pilots with it currently. And then again, there's a whole bunch of people you can choose from. There's a whole bunch of partners. This list will only continue to grow. I'm going to call one specifically Data On. They have a cool story. I'm in the Dakotas, so I'm about 3 hours south of Winnipeg, which is in Manitoba, Canada. Data On, as you can see here, they build these really big, dense servers for Stack HCI for storage scenarios. Well, in Winnipeg, there is the Canadian Museum for Human Rights. It's probably one of the sites you have to see just in Canada as a country. And they have essentially hours and hours and hours of 4K video for recorded oral histories. Plus, they have a ton of security and surveillance camera footage, and then they back it all up, right? So instead of going and investing in SANs at refresh time, they actually just went with these big Data On bulky servers with Azure Stack HCI. And per Chris Rivers, their director of IT, 3 to 4 times the savings instead of going and buying big SANs again, right? And then having to refresh again. They're just using this Azure Stack HCI, which ultimately sets them up to do more with Azure as well anyway. So, okay, so that being said, that's kind of big picture Azure, like physical Azure into platform Azure. And then I'm just going to give you just a quick tour of some services in Azure today. You can actually see if you go on the website, if you click products, you actually get to see those grocery store aisles, right, like I talked about, and then you can dive into the individual products. This is going to be kind of quick, and then I'm going to get into just some whiteboarding on like how you actually think about using this, right? So if you were to dig into the platform, like one of the most common services, right, is Azure Virtual Machines. Windows or Linux, whatever you want, right? You pick the hardware SKU. You can resize it at any time that you want to. In fact, you'll see here, if you dive in, there are different families of hardware SKUs that you can choose from based on the workload you want to run. Again, you can easily resize and move your workload to a different piece of hardware pretty much at any time that you want to. And then again, we give you just an allocation of cores and RAM, and again, you figure out what works for you. If you need to scale up, scale down, that's totally up to you, right? So most common workload we see out there today. We do some really interesting stuff with VMware, right? So we actually run ESX hosts that are integrated in Azure today with the plane. So you can actually use vCenter as a single pane of glass to manage virtual servers running on ESX on-prem, as well as running on ESX running in our Azure data centers, right? And it's integrated with all of the native fabric as well. And you can actually use vMotion quite simply just to move servers from your ES hosts on-prem into the Azure ESX. A little more pricey, right? Because the VMware licensing is baked into that, but again, very popular. And then this is a big one, right? Basically, Microsoft has a first-party VDI service now. It's called Windows Virtual Desktop. The big thing is this. You can do multi-session Windows 10 desktop, right? So it means multiple full Windows 10 client sessions on the same server, right? And it's easy, right? All of the remote desktop infrastructure that enables this VDI service, that's all managed under the hood for you. You just have to think about the host pools. And not only can you get just pure Windows VD, but you can do it with integrated with Citrix, VMware Horizon, or WorkSpot, who's kind of a nifty SaaS ISV who does one as well. And all you technically need is, if you have the right Microsoft 365 or Windows 10 licenses, you've already basically covered the cost of that aspect of it. And then what you'll find is if you're doing any kind of CAD design, this is a great service to use because you can basically stand up these huge NVIDIA powered GPU machines, run them for a little bit, do your CAD work, and then shut them down and save a bunch of money versus going out and buying some big pieces of hardware just on-prem. So Windows VD is also big as well. I'm going to probably skip through the rest of these. Azure Synapse Analytics, this is like a data warehouse as a service. Very, very impressive. I'll talk about that in a little bit. Blob storage, this is like your S3 equivalent to Amazon, right? Comes in a couple different tiers. It's stinking dirt cheap, you guys, like really, really cheap. So people usually find a means for this. Usually storing cold files ends up being a really popular piece of that. And this is kind of a fun one, just to show you some of the innovative services. This is Azure Logic Apps, right? So when you think about your different systems and apps, they need to talk to each other. Maybe they need to send data or messages or all that kind of stuff. And you'll find a lot of companies will go and they'll buy some really big EDI, a data translation engine, or they'll go have a dev team write all these different little app scaffolds to talk back and forth. Well, Azure Logic App, it's actually just it's a low code, no code integration experiment. So you can see here actually in Logic App Designer, you can design the whole flow, automate it without designing any code. And there's all these pre-built connectors you can use. You can see Salesforce call it, you can see SQL Server, where you can set it up, and it's super cheap, right? So again, a great way to get started in Azure in a way that you could probably see some immediate results just on repurposing some of your time and your effort. Okay, and there's more services as well. I'm just giving you guys a little bit of a teaser there. I did see that some people called out in their interest in this session that they were interested in how you bill for Azure. I'm going to try to just make this real quick. You technically have two ways you can go, right? You can purchase directly from Microsoft, right? You can go through the website, or you can go through your Microsoft team, or you can go through a CSP like Vicom. It's really up to you. You have a lot of flexibility in how you want to do that. I'm going to zip through these pieces just for the sake of time. And then when you're in Azure, there's a lot of ways to save, right? It's a utility, right? So it's on demand, which meaning as long as you pick the right amount, right size, that'll keep your costs down. A lot of the services, you can turn them off when you're not using them and thus not bill for them, right? And then turn them right back on and resume where you were. If you are doing like development work on Visual Studio with Microsoft and you have like a Visual Studio subscription, if you're doing dev tests, like you're running dev test servers or environments in Azure, you basically, we give you discounts on that. You can reserve capacity ahead of time and we'll give you discounts anywhere from 30 to 50%. Like I say, you reserve a certain patch of servers that you know you're going to use for a long time. Like we'll cut the costs on it for you, and you can bring your own license, right? So if you have Windows Server, SQL Server, and you have that with like software assurance, you just basically push a button in the portal, and we'll just knock that licensing cost off the price of the actual services because it's included. And then there's this idea of what platform as a service, right? Is instead of managing operating systems and all the applications and the virtual networking, is you just let us manage it for you, like a managed data warehouse or managed compute hosting platform. And there's actually a lot of just TCO savings that you see beyond just the cost of sale, right? This is kind of cool stuff here. I'm going to give you an example of here how the cost savings would work. So let's say you want to run a 4-core 16 gig machine in Azure and you want to attach 250 gigs of SSD to it. Running Windows Server, right? So the licensing is included, right? Per minute, per second. And then let's say you want to run it for 730 hours. That's a full month, right? List price of that machine, $294. That's what's going to cost you, right? Well, let's say you decide to bring your own license with Windows Server because you have it. That drops it down to $160. And then let's say, because just like you buy hardware on-prem for 3 to 5 to 7 years, you know what you need. So you reserve it for 3 years, right? There's some flexibility to get in and out of that and change that. You drop it down to 74. Now let's just say it was a 4-core 16 gig machine on-prem, but your utilization is only like 25%, right? Because everybody over provisions on-prem. Well, let's right size that thing and drop it down to a 2-core 8 gig machine, which drops it down to $47. So in the end, it's like a 70 to 80% savings, right? And again, you have the beauty of scaling at any time that you need to. And then ultimately think about some of the auxiliary Azure costs, some of the other licensing that you're going to work in there as well. And there's actually a tool out there, guys. It's called Azure Migrate. Like Vicom's probably really good at running these things, where you can basically run an appliance. It'll basically look at all of your servers, your metadata, your perf data. It'll map that to Azure and tell you what this would look like running in Azure, either as is or right size, and you can like change the properties. You can factor in reservations or bring your own license, whatever you want, and it will spit out a projected monthly yearly cost for you, right? Which is great. And so here's actually an example. This is the same patch of servers. This is one of my customers, 32 servers, right? One they did pay as you go, right? So no reservations, no bring your own license, and then one they did bring your own license and a 1-year reservation, and they went from that to that, right? Which is like a savings of $40,000 a year. And the tool pretty much did everything for them. So again, this stuff is out there for you guys to use just to help you figure that out moving forward. I've got a couple minutes here before we probably get into the last couple minutes of questions. So I'm going to just try to maybe brisk through some of this stuff. Yeah. So all that being said, how do you think about using Azure, right? Again, there is a path that you follow to get into Azure. And one of the biggest challenges is how do you actually use it? And what people will do is they'll go into the product catalog and they'll see, 200 plus services. And they're like, gosh, there's like 200 different things I can do. And I'm here to tell you that's not the case. There's actually only like 10 to 15 different things you can do. And the major ones are this, right? Should you host your apps on-prem or host them in Azure? How about from a DR perspective? Why not make Azure your secondary site where you don't have to invest in middle, you don't have to run compute all the time like you do with your colo? That's a big one for DR and backup. Or your data warehouse, right? For more advanced analytics, like we're doing some really cool stuff in this space. Or experimenting with predictive analytics, right? We have the compute, the storage, the actual software platform, it's all managed for you. VDI, that's been a big one, especially in 2020. File management, a lot of guys have file server sprawl, and they just want to centralize that stuff or build a global distributed file system, right? Keep it resilient, keep it cheap. That's been a big one as well. Dev test environments, building apps, testing them. That's also huge, right? Because you can shut stuff down. Adding AI to your apps or building automated app experiences. That's also, it's like a whole app factory up there. Building mobile apps. We've got a great story for that one as well. Doing work with SIMs. We got this new Azure Sentinel I talked about, right? These are some of the big use cases. And I try to work through this very scientifically with my customers to figure out, you know, wish list, which ones of these resonate most. Let's start there and then let's work our way through the rest of them. And then you'll see people will take on a whole transformation as they move forward. Here's a great way to get started. If I was you, right, and you haven't done much public cloud, is go catalog your app landscape, right? The first use case is what do we do with our apps? The second is our data, right? So apps, catalog your apps and determine their candidacy, right? Are there internal, external users? Did you build it? Did you buy it? How mission critical is it? Should it just go to SaaS? I actually have a questionnaire that I built that will lead you through the process of doing that on your own. And then when you look through all of your apps, you'll be able to look at some of them and say, you know what, this could be a great candidate for public cloud. And then we just have to get together and we architecturally design it, right? Should it go IaaS or PaaS? Should the database be IaaS or PaaS? How do we make it resilient? And then let's design the architecture, let's cost model, and let's move towards a POC, right? And so what you'll find is if you're going to take an app and stick it in Azure, you have a couple different ways you can deploy it, right? It's all server infrastructure, but how do you want the server infrastructure? So you can go like just virtual servers, right? That native fabric Azure VMs I talked about, or you can do ESX in Azure. We have some purpose-built stuff for SAP. Or you can go some of these like managed compute platforms. Like we have a web farm as a service where we manage the OS and we do the scaling and everything. You just basically deploy your content and your code and we run it for you, right? Great for web apps, websites, APIs, mobile apps, all that kind of stuff. If you're big into like Kubernetes or container-based applications, we have those as a service as well. Doing a lot with serverless as well. A lot of event-driven architectures have become very popular these days. Do some really cool low-code, no-code stuff with Power Apps that actually sits on Azure where you don't have to actually write code. You can use a visual designer to do that. And then lastly, if you've got those classic Windows apps, right, you can just deliver them remotely using our VDI service. So hey, at this point, I've only got a couple more minutes. I'm just going to click through these just so you can see this. We get into what do we do with the database right on the back side. There's some great opportunities there. I'm just going to do this. And we've kind of run out of time here, which is fine. I think there's enough to go forward here. So I'm gonna end on this one. So look, there are some fantastic opportunities to just even start the process of digging into Azure and finding out if it's for you, right? I wouldn't say shame on you to anybody who doesn't use Azure, right? Like I think everybody has at least one use case for it, but there probably is a little bit of shame on you if you haven't looked at it yet. And I know it's challenging. Everyone's busy, everyone's biased, and everyone's unfamiliar, right? And I find these first 3 stages, defining digital transformation, uber hard for people. Validating motivations for public cloud, yeah, kind of hard for people. Envisioning use cases, kind of hard for people. But if you find the right people, like some of the folks at Vicom or myself, and you dig into this, you can build a great plan for getting started with Azure. And I feel like it's December, like we're going to 2020, like what a great time to start the conversation. So Andy, with that, I'm going to stop. I didn't hit everything, but I think there's enough there to chew on.
Thanks, Dane. Great presentation. So now what I'd like to do is open up the bridge for any questions that you might have about anything that we discussed today, be it Vicom or Microsoft. So if you have questions, please go ahead and unmute yourself. Anybody have any questions? If you have questions, now's the time. I know Dane put a lot of information out there for everybody. So if there are questions after the webinar is over, please feel free to reach out to me and we'll make sure we get those addressed for you. Last chance for questions. Okay. Well, thank you for attending our presentation today, and we hope that you found the information useful and, most importantly, relevant to your organization and what you're doing today, especially in today's challenging times where firms are looking to bring as much efficiency to their IT and cloud environments as possible. If you're interested in hearing more about Microsoft solutions or anything that Vicom does, please feel free to reach out to me or to your Vicom account executive. My contact info is on the slide here and in the emails that you receive from me as well. So thank you again, everyone, for attending today, and please continue to stay safe during these times.